Okay. So the next thing that we're going to do is provide the ability to click on a feature and get some attribute information about that feature. So I've got quite a bit of code over here on the right-hand side. We're actually going to write this, but I wanted to take this opportunity before we kind of go into the code along to point out some things that we're going to do. So within the map, we have a signal called operational layers changed. And what that does is it updates it whenever there's a new layer added to the map. And so we can use this signal to retrieve the layers in our web map. And so we'll use this to retrieve the work order. So this is a web map full of work orders, and just by accessing the layer name in the map, we'll be able to get those work orders, that layer. And we need that layer because we need to be able to identify the features on it. And to identify the features, we need to listen for when the user clicks on the map. And so we have a mouse clicked signal that allows us to do that. And so for this, what we're going to do is when the user clicks on the map, we're going to call a method called identify layer. And this is on the map view. So I want to point out that this mouse click is on the map view, not the actual map itself. And once we click on the map and we call the identify layer method, we have a signal to listen for identify layer status changed. And once the layer status or the identify layer status is completed, we can retrieve the attributes of the particular feature in the layer that was clicked, and then console.log those out to the console. So that's kind of an overview of what we're going to do. So with that, let's go ahead and continue on with this code along. So the changes that we're about to make to this app live in the identify features demo. So that code will contain both the just web map consumption, what we have here, and also the identify code. Okay, so the first thing that I'm going to do is write some code to retrieve the layer that I'm going to be working with, which is the work orders layer. Now, let me first show you the web map so you can see what it is that we're consuming. So this is the web map that I created in my ArcGIS Online and shared it publicly. I shared both the web map publicly as well as the layer so that you have access to both, and so that I also made the features editable, because in their next code along, we're actually going to edit these features. So, so you can see here the layer in this web map is called work orders. And so we need the name so that we can reference this in order to retrieve it. We're going to retrieve in this case, we're going to retrieve the layer by its name. And then if I open the attribute table, you can see I have a few attributes here, one called assigned to. I got some work orders assigned to Erwin, Tina, Chris, and myself, the type of work order, and then the status. So you can see that the work orders are symbolized by status. Closed is the red square, in progress is the orange triangle, and open is the green circle. So later on, we'll update the code so that we can edit features to change the status to closed. So it's important here to kind of understand what the symbols are. Okay, so again, our layer is called work orders, so we're going to use the name of the layer in order to retrieve that layer. So one thing that I want to do is in my map, I'm going to go ahead and call that operational layers changed signal so that we can check when the map loads. We can get a reference to that feature layer. So we'll use on operational layers changed. And since this is a signal, we're going to go ahead and use the colon and then the open and close brackets. And let me just quickly also show the help for this particular signal. So if I go, this signal is within the map, and So if we go to the map QML type, and right now I'm in the ArcGIS Runtime for Qt API reference. So if I go under signals, I can see this is a signal I'm interested in. Operational layers changed. Let me make this a little bigger as well. Okay, so I can see that this signal is emitted when the operational layers property of the map changes. So let me go to operational layers. So operational layers is a layer list model. And we talked about models on Tuesday. And so this is the same type of model. It's a QML list model. It's the same type of model that we created on Tuesday, where it's a list model with list elements. And the particular properties of this list model are the ones that you see here. So every layer that gets returned in the list model will have a name, a description, a visible property, everything you see here we'll have access to for each of the operational layers in the map. So what we need to do is access this layer list model, and then we'll check if the name of the layer is equal to work orders. And if it is, we'll get that layer using the get method. So the get method, we'll pass in an index. So we'll use a for loop to loop through all the layers, pass in the index of the layer that matches the name work orders, and we'll get that layer, and that's how we'll retrieve it to use the identify features later on in the code. So let me show you how this works. So on operational layers change, the first thing that we want to do is define a for loop that's going to loop through each of the operational layers that are returned. So every list model has a property called count, which obviously returns the number of items in the list model. So remember, operational layers is a list model, and we're going to loop through all of the layers, all the operational layers. Now, in this particular web map, I already know that we only have one layer, but if you had multiple layers and you were trying to get access to a particular one, you would use a for loop to loop through each of them and then retrieve the layer of interest. So within my for loop, I'm going to check if the layer name is equal to work orders. So if operational layers.get, so get is the method to return the actual layer itself, and then the property that we wanted was name. So we have basically if the layer in our loop dot name equals work orders, so define curly brackets for my if condition, and so I'll define a new variable called feature layer. For right now, I'm just going to make it a local variable using var. So I'll say var feature layer equals operational layers.get, and then the index. So I returns the current index. And then once we find the layer of interest, we'll just break out of the loop because we don't need to continue looping through the operational layers. Again, in this case, we only have one anyway, but if you had multiple, you could break out of the loop using the break command. Okay. So I've currently defined this feature layer as a local variable, but I know that I'm going to need to reference this feature layer elsewhere in my code to be able to identify features within it. So I actually want to make this property or this feature layer a property of the page itself. So instead of using var feature layer, I'm going to remove the var for now, or I'm going to remove it altogether. And I'm going to define at the top of my code a new variable for feature layer. So I'll use property feature layer. So it's the way you define a property is you first use the keyword property, you define the type of the new property that you're creating. You give that property a name, and then you assign it an initial value. So to start, when this app first launches, the value of our feature layer is going to be null. And syntax is important here. So you'll notice that for my actual property name itself, I'm using camel case or this kind of notation, like a lowercase for the first word, and then I capitalize the second word in my variable name. I just want to make sure that the name that I give it is the same as what I used later on in my code when I reference it. So in this case, I used a variable that looks like this, and so you'll see that it's kind of italicized down below, which kind of indicates to me that that this is a variable defined somewhere in my you know, in the higher level of my code. So now that I have my feature layer, I can you know, check for when the user clicks on the map to identify whatever feature is nearest their mouse click. So the next thing I'm going to do is use the mouse click signal to retrieve the click location and then call the identify layer method, which is going to allow me to identify the features in the layer. So outside of my map element, so the mouse click is a signal of the map view. So I want to make sure that this signal handler is within the map view and not the map. So again, outside of my map element, I'm going to set up my signal handler for mouse clicked. So on mouse clicked, and then colon and squiggly brackets, curly brackets. So I'm going to call the identify layer method. And if I quickly go to the help to show you this particular method, so this is going to be under GeoView. So map view is inherited from, or map view inherits the properties of GeoView. So you kind of learn to navigate this help as you start developing apps with Runtime. Sorry for the back and forth. I'm actually just going to go straight to GeoView. So here I am under GeoView, and again, we're using a map view, which inherits the properties of GeoView, the properties and methods and signals. And so under the methods, we can see here is the identify layer. So if I click that, identify layer takes the layer that we're going to identify, the X location of the screen where the user tapped, and the Y location of the screen, and then the tolerance. So the pixel tolerance that you want to provide so that, you know, the user doesn't click exactly on that feature. This provides a tolerance just for some precision. And then if we want to only return pop-ups, which in this case we don't, we want to actually retrieve the feature and its attributes. So we're going to set this particular variable to false. So let's go ahead and define this layer in our code. So the first argument was the layer itself. Well, we just got access to that from our operational layers. So I'm going to define the first argument as feature layer. Next is the screen location. So that's going to be mouse.x and mouse.y. And then the tolerance. So I'll just set the tolerance for this to 15 pixels, and then false because we want to return more than just the pop-ups. Okay, so now we're identifying our layer, and we need some way to access the results. And so the way that we do that is using the identify layer status changed signal. So that's the next thing that I want to define, is the signal handler for that. And that is also on the map view. So just under my mouse clicked signal, so outside of the curly brackets of that, but still within my map view, I'm going to define the unidentify layer status changed. Now, you want to be really careful here because you'll notice that there are a couple different signals that look exactly the same, or not exactly the same, but very, very close. So you have unidentify layer status change, and then you also have unidentify layers, plural, status change. Now we're using identify layer because we want to only identify one particular layer. But you do also have the option to identify multiple layers. And if you did call the identify layers method, then you'd want to make sure to use the right signal handler to retrieve the status. So in this case, we're using just the singular version. So for my signal handler, I'm using unidentify layer singular status changed. So you're gonna, this is kind of the first time that we're introducing this pattern of, checking for a status change and then checking that the status is completed. And as we go through the next few code alongs, you're gonna see that this is a typical pattern. So it might look foreign right now, but it's something that you're gonna get used to because this is kind of how all of the methods work in runtime. You call a method and then you need to get the results of that method. And so to do that, you check the status of when that method is completed, and then you can actually retrieve the information that you're trying to retrieve. So what we want to do is once the layer status changes, we want to check for when the layer status is actually completed. So I'm introducing this for the first time, but like I said, this is going to become second nature as we go through these next few code alongs. So to check if the status is completed, we call identify layer status, and we want to see, so we use triple equals because we also want to compare type. So we have an enumeration for task status completed. So we're saying once the status changes, it'll go through a series of in progress, I think, and then there's an error out, but we want the one that when the status is actually completed. And so what do we want to do when that status is completed? Well, we first want to retrieve the feature nearest the user's mouse click. So this identify layer status signal has a property called identify layer result. So I'm going to define a feature. So using var and then the variable name, in this case feature, I'm going to use that property that is within the signal, identify layer result. And again, I want to make sure here that I'm using the right thing. So I'm going to use identify layer singular result. You have to be careful because there is a result for the plural version as well. So identify layer result. And this property has a property called GeoElements, which returns the features. And I just want one feature. I want the one feature closest to the user's mouse click. So I'm going to pass in the index for 0. Now, one thing, what if the user clicked in an area that it was not within 15 pixels of a feature? Well, then this would actually return an error because there would be no geo elements returned from the mouse click. So what I'm going to do is I'm going to put this inside of a condition to only run if the geo elements actually contains some features. So I'll put this in a condition. If identify layer result dot geoelements dot length. So geoelements is an array, and arrays have a length property. And I'm going to check if the length of that is greater than 0. And now I want to put this option to retrieve the feature inside of that condition. So I have my feature. Now I have my feature. I can access the attributes of this feature. So if we go back to the map, you'll see that the attributes that I have are assigned to, type, and status. So if I want to get the, let's say type, I'm going to create a variable to store the type, and all I do is call the attributes property of the feature, so feature.attributes, and then the attributes property has a method called attribute value. And all I do is type in the name of the attribute, which in this case is type. And I can do the same thing for the other two attributes, just to get all three of them in this case. So I'll create a variable to store the assigned to and set that equal to the attribute value of that attribute. And same for status. And now, I could create a nice fancy UI to display the attribute values. In the interest of time, I'm not going to do that. I'm just going to console log them out so that we can see the values when the user clicks. Given the things that you learned on Tuesday about creating QML objects and components, you could use, for example, a nice drawer that automatically opens to show these attributes. So I'm going to say log attribute values. So I'll use console.log and print the type. The assigned to value and the status. Okay, I'll leave this up for just a second if you're following along. And I know that I'm going a little bit quicker. So if you're having trouble keeping up, just because maybe you've got only one screen, so you're switching back and forth, feel free to just take this opportunity to just watch and know that you have access to this code. So you can refer back to it later on if you want to kind of go through this exercise at your own pace. So I'm going to go ahead and run the code here. And now when I click on any of these features in my map, you can see down here in the console, I can see the type, the assigned to value, and the status for the feature that I clicked on. Now it would be nice to know what feature that I clicked on. So let's say, for example, there's a lot of points in one area, or I'm zoomed out really far. It's kind of hard to tell what feature I clicked on. So one thing that I want to add to this code is the option to, or the ability to select the feature that the user has clicked on, so we know what feature that is. So that's what I want to do next. So right here in my identify layer status changed code, my signal handler, after I retrieve the feature, I'm going to go ahead and call a method to select it. So I'll say select feature. And this method is actually on the feature layer itself. So I'll call feature layer.select feature, and then we want to pass in the feature that we want to select, which we've defined just above this feature. Okay, so I'm going to run this. And now you can see when I select a feature, it kind of uses that default cyan color that we're all used to seeing if we're familiar with ArcGIS, like ArcMap or ArcGIS Pro. And you'll notice as I continue to select features, they all get selected. That's not really what I want. When I select a new feature, I only want to select that feature, not the others. And when I click on the map and I'm not near any features, I don't want any features selected. So there's one line of code that we need to write to kind of make this work exactly the way we want it. And that is that when the user clicks on the map, we want to clear the selection altogether. So if I go back to the on mouse clicked event, just above the method to identify the layer, I'm going to call clear selection on the feature layer. So each time the map is clicked, it'll first clear the selection. If a feature is found within 15 pixels, it'll retrieve that feature and select it and get the attribute values. So I've just called clear selection on the feature layer. And instead of using that cyan color, I actually want to change the selection color, and I can do that. That's possible with Runtime. And the location that I'm going to do that is actually when I retrieve the feature layer under the operational layers change signal. Once I retrieve that feature layer, I'm just going to go ahead and set its selection color property to orange, just so it kind of goes along with the theme of my app. Okay, so now I'll run this. And now click on a feature, the selection color is orange. I see the values printed out. I click on a different feature and only the feature I clicked on is selected. So that is the functionality that I was expecting to see. So that's how we can identify features when the user clicks on the map. So it's really just a series of methods and then signal handlers to handle the results that are returned by the methods. And you're going to see that pattern as we continue. Okay, so any questions before we move on to the next slide?
Hi, I have questions.
Sure.
What if I click the feature in the application? What would be code for see attribute table in the application? Basically.
Yeah, so in order to see an attribute table in the application, you'd actually have to write the code to show that. It's not just something like a web map. You click on show attribute table and it shows you. That's all. That would all be custom code.
How can I reach such a kind of this code? And maybe I missed the point. Which platforms?
Can you repeat that part of the question?
Sorry. How can I reach this such a kind of codes in
Like
or
a sample?
yes.
Well, let's see. Erwin, do we have samples for, I mean, yeah, map viewer shows the attributes, right? It's kind of got
Yep.
like so that would be a good place. Like you would, I think ideally instead of showing a table, you would have like a drawer or something like a QML component pop up to show the attributes. I could show you a quick sample of what I mean by that. So what I'm getting ready to show you is an app that's actually developed with AppStudio, and it's in Google Play and the Apple Store, and it's an app for trails. And when I click on any of these trails in the map, you'll notice that a little drawer pops up, and that drawer contains the attributes,
Yeah.
in a
Yep.
nice, like, easy to read. So I don't think you'd necessarily create a table, right? You would kind of, since this is an app, you'd make a nice, like, user-friendly version to look at the results.
Yeah.
Brooke, expanding upon that, are there other controls such as grid controls, accordion controls, things of that nature that can be used?
There are grid controls. Like, are you talking about a grid as in like showing a table kind of grid?
Yes, exactly. And having editable control over the cells in the grid and some of those complex things like that.
I'm pretty sure that there is a table control. I haven't actually ever used it. Erwin, have you ever used a
Uh,
table?
no, I have not, but that's just a UI. But what we are trying to show you here that you can get all of the attribute information from all of the features. I mean, the information can be it's here. I mean, if you say features dot attribute, and that is the JSON value of all of the attribute in the features. How you're going to display, that's up to you. I mean, we can go through, there are like, that's why this is the model. The model has all of the data, and then the table, or I don't know, pie chart, or however, like Brooke showed in the accordion, look like those are the delegate on how it's going to look like. So right now, if we say console log features attribute to string on this on this one, it will give you all of the attribute. So the features that attribute, that is uh, the model for all of the attribute that the features have. So how
Right.
you
So what you're saying is there's a series of controls that are in the library that's out there.
yep, yep,
It's been difficult finding any direct documentation to it to show all of the controls and controllers and things like that. So
right,
if JSON data pack comes back,
yep,
then I want to use it and view it in a particular manner.
yep.
Those
Yeah.
references would be helpful.
Yeah, so this is the table view QML type here, that, I think it sounds like you might be looking for.
Perfect.
Yeah. Yeah, and there's infinite, I mean, there's, like, it's limitless what you could do, right? So we've never had I think a table would be more something that you would use on, like, a desktop device, but if you're like developing a mobile app, then you want to provide, well, I guess also depending on the application, but you may be more interested in, like, a drawer or a pop-up or something, but there are table views, that you could use as well.
Yeah, the difficult thing I think I find is that, even watching this, you guys keep bouncing back and forth between the Qt documentation and then Esri AppStudio documentation. There's not like one, singular set and so on. So there's the Qt framework underneath all of this, and
Yep.
then the SDK, Esri SDK sitting on top of that to extend and enhance and then do some of the geo things.
Yeah.
And so it's difficult finding that single resource.
Yeah. So I mean, that's how our technology stack works. We use the Qt quick library for the UI. We use ArcGIS Runtime Qt for all the mapping technology, and then our own AppStudio framework for anything in between. If I mean, the easiest one to look at how it works is to be inside the Qt Creator. If you don't want to be looking at the website in Qt Creator itself, it has a built-in documentation that you can, if you hover over one of the object and click F1, and you would get the specific page for that object.
Yeah, but that's only if you already know about the QML type, right? Like, then you can hit F1. Is that what you're saying, Erwin?
Yep.
Yeah.
Correct. This slide is actually perfect. This is exactly what I've been looking for. Short, sweet, and tells me exactly where to go to
Yep.
look for what.
Yeah, yep. So yeah, definitely any of the components themselves, you're going to find those. Those are totally separate from Esri, and so you'll find those in their own Qt documentation. All of our runtime components are going to be, on our website in our API reference, and then you'll find the AppStudio app framework pieces in a separate location as well.
Perfect. Thank you.
Sure.
Brooke?
Yes.
One small question.
Sure.
Can we integrate with external services in the Qt JavaScript?
External
Like
services.
Ajax?
Like Ajax?
No.
Yeah.
Only vanilla JavaScript. Ajax call, yes. There's asynchronous programming, but jQuery is not supported. Like you can use XML HTTP requests. You can do that. We have our own as well, network requests. But remember, the JavaScript that is supported here is only vanilla JavaScript. No DOM related JavaScript like jQuery, let alone Angular and all that.
Sure.
Yep.
Thank you.
Kind of going along with that, if I show you this app, as far as requests, one thing, that we've done, and it's in this app is a request, like a REST request, HTTP request that goes out
XML,
to,
yep.
thank you, and return some JSON values. So in this case, we are using the NOAA weather service to pass in the lat long of a location, and it returns back the weather information. So those kinds of requests you can do. Okay, so the next thing that we're going to do, we're going to add on the capability to now edit our features. So we've got a map that we're able to view. We're able to click in the map to identify features. And now what we want to do is actually, in this sample, we're going to just click on a feature and then allow the user to click a button that will close the work order. So again, this is kind of a highlight from the code that we're about to write. So we're going to create a button, and we're going to use that button to replace the attribute value of the status attribute, and then apply those edits. So a few things I want to call out here. We're going to use that replace attribute method that's on the feature object type. So the feature has attributes, and then the attributes have a method called replace attribute. So we'll use that. Then we would call, we're going to get access in this sample to the feature table. So the feature layer is just, the actual features themselves, just the layer. But we also want to be able to access the feature table, which is the data behind the layer, basically kind of like you could think of it as like the attribute table. So we'll get access to the feature table. And once we have access to that, we'll be able to update that feature, calling the update feature method. And just the same pattern that we've seen before, when we call a method, we need to be able to get back the results. And so in this case, we're going to create a connection. This is something new, but once we have a connection, we're going to have a signal to actually get back those results. We're going to check for when the feature status change is complete. And then we call the apply edits method to actually apply the edits that we made to the feature. So, and then we can, again, we call a method, we have a signal to capture the results. We'll just print out, that the edits were applied. Sorry, was there a question? No. Okay. All right, so let's go ahead and get started with this last hands-on code along for this particular app. So again, we're just going to update the work order status to close on the selected feature. So you'll see we're going to create a new button down there in the right-hand corner. So I'll go back to my code. Okay, so I mentioned that we're going to need access to this layer's feature table now. And we're going to need to be able to use it throughout this component. So I'm also, in addition to creating a property for the feature layer, I'm also going to create a property for the feature table. And to do that, we're going to use the service feature table type, because this is a online layer, so it's a service feature table, and I'll just define the property as feature table, and we'll set it to null when the app first launches.
Just by the way, that actually was required in the last step to preserve the orange color, right? I was still getting cyan on my selection until I put the feature table property there.
So the feature table isn't needed for the changing the selection color. The selection color is only a property of the feature layer itself. So you'll notice I don't have a feature table yet, and I changed my color to orange. So you just want to make sure that you that you call the selection color of the feature layer. So now that we have our feature table, we'll go ahead, or our feature table property, we'll go ahead and assign the feature table after we retrieve the feature layer. So we can do that just after we get the feature layer. The feature table is a property of the feature layer. So we'll set our feature table equal to feature layer dot feature table. Okay, and now I want to go ahead and create a button that will be on the right-hand side of the and bottom of the page that will allow us to close a work order that is selected. So all the way underneath my map view, but still within my page. So if you want to scroll up and click the curly brace next to the map view, I think you can also just collapse the map view, and you could do it that way, and then just add a space between the page and the map view. Either way, you just want the button that we're going to create just outside of the map view. So just outside that curly brace. So I'm going to define a button, and again, this is a QML object now. So any of the UI components that we're working with are QML, versus the GIS mapping components are runtime. So we want the button to say close work order. And I'm going to give it a material background color of orange, just like we set for the toolbar. We learned about anchors on Tuesday. It's one of the ways that we can position objects and elements on the page. So I'm going to create an anchor for this button, and I want to anchor it to the bottom of my app. So I'll say bottom equals parent.bottom, and right is parent.right. I don't want it to be right on the edge, so I'm going to give it some margins of 20 pixels. Okay, and then just outside of my anchors, I'm going to define the on-click signal. So I'm going to create a signal handler for on-clicked. Now, what happens when I click this button? I want to update the attribute of the status for the selected feature to closed. So to do that, I actually need to grab the feature. And currently, the feature is a local variable that only exists inside of my onIdentify layer status changed signal handler. So I want to create a global variable that exists at the component level rather than a local variable. So just like what I did with my feature layer earlier, where I redefined that above and removed the var, I'm going to do that for the feature as well. So we'll remove var from where the feature is defined inside of onIdentify layer status changed. And up at the top of my code, I'm going to create a new property for feature. So this is of type feature. I'm going to call it feature. And when the app first runs, I'm going to set it to null. Okay. So now my feature is accessible all throughout this particular app. So when I have my onClicked, I only want this code to run if a feature is actually selected, because this is going to run only on the selected feature. So I'm going to have a condition if feature, and that just basically means if the feature isn't null. And then the method to replace the attribute is under the attributes property of the feature. So I'll call feature.attributes and then the replace attribute method. And this takes two arguments. The first is the name of the attribute and then the value that I want to replace for this feature. So the name is, we're going to replace the status. So the name of the attribute is status. And we're going to set that attribute to closed. Okay, so we've replaced the attribute, and you could replace multiple attributes, right? We could also choose here to replace the name or the type as well. I'm just gonna, just to keep things simple, only replace one attribute. And then when you've replaced the attribute, the next thing that you want to do is call the update feature. So again, here, we're only updating one feature, but you'll notice there's a method called update feature and one called update features, and that's if you are updating multiple features. So for this, we're just going to use update feature, and we pass in the feature that we just updated. So we updated the attribute, and now we're going to call the update feature method on the feature table. Okay, so just like what we did earlier when we identified the layer, we called identify layer, and then we need some way to get back the results of that method. And the same thing is true for when we update a feature. We need to get back the results of this update so that we can then finally apply edits, which actually is basically like saving your edits if you're in Pro or desktop. So, so we need a signal handler to handle the update feature. Now, before that was pretty straightforward because we were able to define that signal handler right inside of the map view component because we have we have defined the type for that. But because we are grabbing the feature table dynamically, we don't have this nice component defined where we can insert that signal handler. So the way that we're going to access the feature table is through what's called a connection. And this is kind of getting a little more advanced, but this is a good way for you all to see, exactly how we would do this in QML code, without, trying to keep it really simple. This is actually the real deal here. So, and the more that after you do this a couple times, it really just becomes second nature. So we're going to define what's called connections, and then we just set a target property. So in this case, the target is our feature table. And now that we have this set, we can define signal handlers within this connection for our feature table, just as we did, above for our on mouse clicked and on identify status, layer status change for the map view. We can do that now for feature table within the connection. So what we want to do is check for when the feature status is complete. So again, we're going to use the same kind of notation, same pattern, using the signal handlers for on update feature, and it's singular here. Make sure that you use on update feature status changed. So just like before, I'm checking for the status changed, but there's, there's in progress, there's errored out. I want to know when it's completed. So I'm going to use a condition to check feature table. Because I'm in a connection now, I need to define the object dot the status. So feature table dot update feature status. And I want to check when that's equal to, again, task status completed. And when it is completed, that means the updates have completed. So I want to actually apply my edits. And that's the method that I need to call to make sure that these changes are pushed through to the feature table. So to do that, we'll call the feature table dot apply edits method. And again, the apply edits method, also has a signal handler. So apply edits, once we apply the edits, everything's kind of done from our perspective, but I'm just going to create a signal handler for apply edits just to console.log out that the edits have been applied. So just like you've seen before, we're going to create a new signal handler on apply edits changed. And we're going to check the status. So if feature table dot apply edits status equals task status completed, then I'm just going to print out that the edits were applied. Okay, so I'll leave this here for just a second, and then we'll run this and see how it works. Okay, so go ahead and run this. And you see our button down here now. Oh, looks like some people are already running this. And yeah, it's open to everybody. So yeah, if I click on a feature and choose close work order, you'll see that that feature then changes symbols to show that it's closed. And you could just as easily change this if you wanted to update your code, right? You could change, maybe you want to change the status to open. And I'm just going to change the name of my button as well, just so we can open up some of these. So I'll just say open work order. And now I can run this and open a few of them. Oh, looks like somebody's already doing that too. So great. So yeah, I think it looks like a lot of you, or at least some of you, are have your app working and are going in and making some changes to the status, which is great. Oh, and I do see I have an error because I was expecting to see on the console edits applied. So on apply, oh, I have a typo in my signal handler. So I want to have on apply edits status changed. So now when I run this, you can see, I see that the edits were applied. Okay, so that is, that's the last hands-on exercise for this particular app. And let me know if there's any questions before I move on to the next slide.
Brooke, once the edits are applied by someone, because we are using the same map, right? So
Yes.
I need to refresh the map to reflect their changes?
Yeah. So, yeah, the way that I've done that in an app before is I have like a refresh button and it reloads the map. But yeah, you have to refresh the map.
Okay. So on the fly, it will not reflect the map, whoever updates.
And you could have like when the user moves the map, automatically refresh, or you could have it on a timer to just, constantly refresh like every few seconds.
Okay. Set refresh interval on web map will solve, right?
Sorry, say again?
Set refresh interval on web map will solve this problem, right?
I don't, Erwin, do you know? I don't think that will, I don't think the refresh interval on the web map works the same in the app.
Yeah, the refresh interval is if someone else is making an edit, right? And then we are seeing that changes. We in the app has to change that. We in the app has to get
Refresh.
that changes. Yeah, somewhat refresh our local model to grab the changes from someone else. So
Understand. Yeah.
so imagine every time this code runs, we have quote unquote a local copy of the model, and then if you refresh that model, then a request will be made into the ArcGIS server, and then grab whatever the latest data looks like, and then update that.
But the property set on a web map, the set interval,
Yeah, that is
mean for that one, right? So it's like automatically refresh wherever you load the web map, because here we are loading the web map. That's the reason
so
I'm asking. Like
that is reverse interval. In our opinion, that is on the server side. That's how the server side is being refreshed.
Okay.
I mean, this is the client side who's consuming that data. I hope that answered the question.
Yeah, thank you.
Yeah.
Hey, so does it refresh like with the ArcGIS JavaScript API? Just when you zoom in or zoom out, then that grabs a new view and then it refreshes it. Does that work the same here?
Yeah. On the web, when you zoom in and zoom out, it actually make a request again, right? So
No,
the JavaScript API behind the scene do that request for you. On this case, it's the same as panning and zooming. If you pan and zoom on the app, then runtime API behind the scene grab the latest changes for you.
So it's the same. So zoom and pan, it would work the same.
Yeah. Well, if the app is not if you don't touch the app, you have to have a code that will do that. But if you pan and zoom, then the runtime, the same as the JavaScript API behind the scene, get the latest information.
Sorry to interrupt you, Erwin, but the set interval on a web map, actually, I don't need to do a pan and zoom in of the map if I'm using a web map.
So
in
again,
JavaScript web application.
Really?
Yeah, I don't need, even in dashboards, like I just open the web map and then set interval will refresh my activities on my map.
Okay, let me check if there's a refresh interval on runtime Qt. Without panning and zooming? There may be a refresh interval on the JavaScript API itself, or it grabs. I have to check the documentation regarding that. One second.
Hosted feature service layers do have a refresh interval that you can set that will do that without touching anything, panning, zooming, doing anything.
Again, we are all talking about the server side. We have to look at the ArcGIS Runtime SDK for Qt.
Agree.
Yeah, so that's what I need to look at right now. So 1 second.
Sure. Thank you.
Yeah.
Thanks, Brooke.
If there is any refresh interval. Yep. Just give me a second. I need to look at.
Yeah, sure. Erwin, while you're doing that, should we take a quick 5-minute break?
All right. Okay. So I think I found it.
Okay.
We have the refresh interval. So you need to set this. So I'm going to put it in a chat window. So So you need to do it on the app side. Again, all of those things that we mentioned are on the server side in our point of view. In our point of view, those are happening on the cloud. We are running things quote unquote locally in our on our device. So we have to set this refresh interval on the feature layer.
Okay, I can try that too.
Yeah.
So Erwin, basically that just creates a synchronized caller to
Yeah.
query the request every so often.
So the runtime would do that. So I think how the JavaScript API works, maybe it grabs that value from the web map and then it overwrite the value on their client side because they're also a client, quote unquote. And then they're probably synchronize that value together and then do the request behind the scene.
I'm guessing this is milliseconds, right?
Millisecond, yeah.
Okay.
And that's probably the exact same one. So if you're doing web app development in any of the tools through ArcGIS Online, it's the same call feature layer.
Oops. Yeah, there we go.
There you,
Great.
you got it right.
Yeah, I learned something new.
Beautiful.
Great. Awesome. It's really cool.
So, yep.
Thank you.
Oh wow, things are changing live, huh? All right.
Yeah. Very cool.
Can you move that so I can see the line again?
Sure. Yeah. It's this one right here. So this is milliseconds, so this will refresh every 5 seconds.
What's also really nice about that too is this is taken advantage of in the applications on things like Mission Manager and others where you want to have real-time updates in the field for emergency, for example, and people are on the opposite sides of the blocks of the city, whatever, doing their thing. And as they're updating things, even their locations moving around, you can have those multiple apps all showing this happening in real time or near real time based on your cellular network.
Yeah, that's great. Yeah. So in the past, I've just, I don't know if this is a new property. It's definitely not one that I was familiar with. So I have had the need to refresh, and I just had a refresh button that you had to, manually click. But obviously this is much nicer.
I mean, it might have changed to like maybe for, of course, I think Brooke didn't set the refresh interval on your feature layer, right?
Yeah, I created that web map. I didn't set a refresh interval on it.
Yeah, so this also can, I mean, if you don't have that, you can set how often your local app refreshes it, meaning that if you are on Wi-Fi, it may refresh, a lot sooner. If you're on 4G or LTE, it will refresh a lot later, for example.
That's true, Erwin. The one other thing that's beneficial to this too is if you set it at the layer level, you may have some layers that have crucial emergency information that you need to update every 1 second, and others that don't need to update for 5 seconds or 15 seconds. So it's very helpful.
Yep.
Okay, great. Thanks you guys for asking about that, because this is really, really good property to know about, and yeah, one that's new to me. So thank you. Should we take a quick break, like 5 minutes or so?
Yeah, let's take a quick break.
Okay, so come back at like, I guess it's a weird time, but 10:42.
Yeah, we give 5 minutes.
Okay, sounds good.